Hey everyone, welcome back. In this video, I'm going to show you how to create a custom multi-texture material for your floor generator mesh in Unreal Engine. First up, let's create a multi-texture setup from scratch. I'll be using these colored stone tiles as our base to show you exactly how the logic works inside the material editor. As you can see, I already have floor generator materials copied to my content folder. Check out the video in the description on how to do that. Now I'm going to create a new folder for this tutorial. And inside the tutorial folder, I'm going to create another two folders: textures and materials. Let's go ahead and import our textures to the Unreal Engine. We can do that by simply drag and drop textures into the content browser. Now let's go to the Materials folder and create a new material. I'm going to give it a clear name. MT in the prefix stands for MultiTexture. Now we can open our new material and add some nodes to it. First of all, let's add all the textures we need for our multi-texture material. In this example, we have 12 textures, and the trick to add all of them to the base color input of the material is to create a texture array. Let's fix its name and take a closer look at it. As you can see, this single item contains our all 12 textures, and we can simply drag and drop it to the material editor. Once we connect it to the base color material input, the error in the texture array node will appear. The reason for that is that we need a proper UVS input to the texture array. The multi-texture UVS input has already been set up as a material function and can be found in the Floor Generator Materials Pack Functions folder. Find the mf_UVS_multi-texture material function and add it to our material. The error is gone now. Save the material and find it in the Materials folder. Apply it to the flooring object. As you can see, it still doesn't look the way we want it, but we are almost there. The only thing left is to create the material instance and set one very important parameter for the multi-texture material. Go ahead, right-click the material and select Create Material Instance. Adjust its name and apply the material instance to the flooring object. Now, when we open the material instance, you can see there are some UVS parameters. They are coming from the material function we connected to the texture array UVS input. And now it is very important to specify the number of textures we want to use in our multi-texture material. Let's set texture count value to 12, so our material uses all 12 textures, form the texture array. You can see now that our flooring object got different tiles textures. There is also plenty of other parameters that are coming from material functions. For example, it is possible to adjust each board texture rotation, location offset, and scale. It is possible to add even more useful parameters by using additional material functions from Functions folder. Let's add Hue Saturation Value material function and put it between texture array and base color input. Let's also add Random Color Multiply material function and add it right after HSV node. And another useful material function is Color to Roughness, which allows to use diffuse maps for roughness input. Save the master material and go back to the material instance window. You can see now how many more parameters we got. Now we can add some realism to the flooring darkening boards by a random value. we can also improve material look using these color and roughness parameters. The best part about this setup is its scalability. You can create as many material instances as your project needs, allowing you to tweak the unique parameters of each one independently. Now, let's take a look at another case when creating multi-texture material. For this example, I generated a herringbone pattern flooring just to have a different visual effect. We can already apply one of the materials we created before to have clear lines of the pattern. In this example, we'll be using a set of oak board textures. We have both the base color and normal maps, and we'll use them to build our material. Let's navigate to Textures folder and create a new one called American Oak. Now, let's import all the board textures to the content browser. Once it's done, we select all base color textures and try to create a texture array, just like we did in previous example. Right-click, Create Texture Array. Rename it and press Enter button. And we got an error message. Failed to create asset. And this is exactly what I wanted to showcase in this example. Let's go to the output log and find the reason we got an error while trying to create a texture array. And right here, you can see the warning. The textures have different sizes. For texture arrays in Unreal Engine, it's essential that every texture has exactly the same dimensions. If the sizes don't match, the array won't work correctly. Let's go to the folder with our textures and check resolutions of two textures. As you can see right here, they have different width and height dimensions. To fix this problem, we need to resize all the textures to have the same resolutions. There are many ways to do that. I usually do that in Photoshop. Using actions, I speed up the process. But while making this video, I found about a very useful set of utilities from Microsoft. It is called PowerToys. You can find it in Microsoft Store. After installation, in the Windows context menu, there will appear a new button, Resize with Image Resizer. Click on it to open Image Resizer. For the new image size, select Custom option. For size values, input the pixel sizes that are close to the original image's sizes, so the images are not stretched too much after resizing. I would like to use the opportunity and reduce the size to have 4K on the bigger side. Then select Stretch for the resizing method and optionally select Overwrite files. Make sure you have a backup of the original files if you do that. Click Resize button and it's done. Now, when all textures are the same size, go back to Unreal Engine and delete old textures. Then import resized textures. Now repeat the process again. Select all the base color textures and create a texture array. Since all the texture are the same size, this time we don't have any errors. Our texture array was created successfully. Now let's do the same for normal maps. Finally, we are ready to create a new multi-texture material using these two texture arrays. Instead of creating a new material, we can duplicate the existing materials and edit it. Let's rename it to Wood, Oak, American White. Open Material and delete the old texture array asset. Go to the content browser and find our oak wood texture arrays. Add base color texture array to the material and reconnect the nodes. add normal texture array to the material as well and connect it to the normal input of the material. Don't forget to save the master material. Now, let's create the material instance of our oak wood material, just like we did it in previous example. Let's open it and apply to the flooring object. As you can see, it only uses a single texture from the texture array. So let's change the texture count value to the value of the textures we have added. Now, our flooring looks beautiful and much more realistic. We can also improve it by adding some random color darkening. Roughness channel also gets base color textures as an input, so let's go ahead and tweak it a bit with these parameters here. And that's how you create a custom multi-texture material for your floor generator mesh in Unreal Engine. With this setup, you get full control, clean variation, and a much more flexible workflow for your floors. If you found this helpful, don't forget to like the video and subscribe for more Unreal Engine and procedural workflow tutorials. Thanks for watching, and I'll see you in the next one.